Here's a quick visual recap of supervised learning. In this example, the training data consists of labeled images of apples and bananas. The machine learning model is trained on this data, learning the patterns that distinguish apples from bananas. Once trained, the model can take in unseen, unlabeled data like a new banana and classify it as banana based on what it has learned. This perfectly illustrates the idea behind supervised learning. The model is trained on labeled examples, apples and bananas, and uses the knowledge to make predictions on new unseen data, a green banana. The entire process depends on supervision provided by the training data, which tells the model what the correct answer should be. In summary, the supervised learning teaches the model using labeled data, and once trained, it applies these learned patterns to classify new data. Here's an interesting challenge. Looking at this object, how do you think the model would classify it? If a model was only trained on apples and bananas, what happens when it encounters something completely new, like this mystery object? The model might try to classify it as either apple or a banana based on patterns it has learned. But here's the catch. Models can only classify data based on what they have been trained to do. If they haven't seen anything like this before, they might get it wrong. They will get it wrong. In this case, the model might confidently classify this as banana. Why? Because it only knows apples and bananas, and the shape of the object resembles a banana in this model. This illustrates a key limitation of machine learning models. Models will force unfamiliar data into familiar categories. That's why diverse training data is essential to building accurate, reliable models. Now that we have explored how important it is for models to learn from labeled data, here's the next big question. Is your data labeled? As this meme humorously points out, data scientists often get excited about new machine learning projects. But then comes the reality, data labeling. Labeling data can be very time consuming, but it is absolutely crucial for supervised learning models. Without labeled data, the model has no reference to what's what. So what happens when you don't have labeled data? This is where we move on to a different approach, clustering. In clustering, we use unsupervised learning, where the model isn't given labels. Instead, it looks for natural groupings or patterns in the data, even when we don't explicitly tell it what's what. Next, let's dive into how clustering works and how models can group data without needing labels. In unsupervised clustering, the model groups data based on similarities it finds, but it doesn't know what these groups represent. For example, it might create cluster 1 for long curved objects and cluster 2 for round objects. But the model has no idea that cluster 1 is bananas and cluster 2 is apples. It's just looking for patterns and grouping similar items together. Once the model forms the groups, it's up to us to find out what these clusters mean. We, the humans, have to look at the groups and say, this cluster means bananas and this cluster means apples. Some real world examples: customer segmentation. A business might want to group its customers based on behavior. The model might group people who shop frequently into one cluster and occasional buyers into another cluster. But it wouldn't know which is which. This is where we step in and label them as loyal customers or infrequent customers. Other example is image grouping. If you have a massive photo library, the model might cluster different pictures or images together with similar colors and shapes, like sunsets in one group, cityscapes in another. But it is up to us to recognize how to label these clusters as sunsets or cityscapes. So the model does the heavy lifting of creating these groups, but we are the ones who give meaning to these groups by figuring out what they actually represent.